At the end of the topic, you will be able to recall collection of data, presentation of data in tabular form, ungrouped and grouped data, construction of histogram and frequency polygon. Construct histograms with varying base lengths.
Statistics and its applications. Statistics is considered as the mathematical science pertaining to the collection, analysis, interpretation or explanation and presentation of data. Here are some of the applications of statistics to show the information in the form of figures, tables, and graphs. In cricket, the bowling and batting averages of a cricket team. In stock market, the stock exchange Sensex rate. Growth charts are used to compare a child's height and weight to a standard range.
Let us learn the two types of data. Primary data is the data obtained in the original form. It is ungrouped data or raw data.
Secondary data is the raw data that is condensed in the form of groups. It is grouped data. The grouped data is usually represented in the form of a table called frequency table. Let us now see the inclusive and exclusive classes. Inclusive classes. The upper limit of one class does not coincide with the lower limit of the next class. Exclusive classes. The upper limit of one class coincides with the lower limit of the next class.
Let us define histogram. A histogram is a graphical representation of a frequency distribution in the form of adjacent rectangles with class intervals as base and heights proportional to the frequency of those class intervals. Here are the steps to draw a histogram. Step 1. Convert the class intervals in an exclusive form if it is in inclusive form. Step 2. Taking suitable scale, mark the boundaries on x-axis. Step 3. Taking suitable scale, mark the corresponding frequencies along y-axis. Step 4. Construct rectangles with class intervals as bases and corresponding frequencies as heights. Let us learn about frequency polygon. A frequency polygon is a graph of a frequency distribution with class intervals on x-axis and the number of observations on y-axis. Data points are plotted at the midpoints of the intervals and are connected with a straight line. The two endpoints of a frequency polygon always lie on the x-axis. Frequency polygon can be drawn in two ways, with histogram, without histogram.
To graph histograms with different class widths, we need to calculate the heights of the rectangles of the histograms. First, we have to find the frequency density. Frequency density is equal to frequency by class width. Then, the length of the rectangle is equal to the product of the frequency density and the minimum class width of the given data.
Let us see an example.
Click on the solution button to view the solution.
Here is another example.
Click on the solution button to view the solution.
Let us see one more example.
Click on the solution button to view the solution.
In this topic, you have learnt to construct histograms with varying base lengths.
At the end of the topic, you will be able to estimate the mean of the ungrouped data, compute the mean of grouped data. Here is an example. The bar graph displays the scores of 10 students. Find the mean score. Click on the solution button to view the solution. Let us first see the arithmetic mean of ungrouped data. Let x1, x2, x3, and so on, xn, be n items. If the arithmetic mean is denoted by x bar, then the arithmetic mean of the ungrouped data is given by x bar is equal to x1 plus x2 and so on plus xn divided by n, which is equal to sigma I is equal to 1 to n xi divided by n, where sigma I is equal to 1 to n xi is equal to x1 plus x2 and so on plus xn. Here is an example. The bar graph displays the scores of 10 students. Find the mean score. Click on the Solution button to view the solution. Arithmetic mean of discrete data. Frequency. A frequency of an item is the number of times the item occurs. It is denoted by the letter F. AM of discrete data. If x1, x2, x3 and so on, xn are the items and f1, f2, f3 and so on, fn are the corresponding frequencies, then the arithmetic mean is given by x bar is equal to x1 f1 plus x2 f2 and so on plus xn fn divided by f1 plus f2 and so on plus fn. X bar is equal to sigma fx divided by sigma f. Here is an example for finding the arithmetic mean of a frequency distribution. Find the arithmetic mean of the given frequency distribution. Click on the Solution button to view the solution.
There are three methods to calculate the mean for grouped frequency distribution: direct method, assumed mean method, step deviation method.
Mean of a grouped data. If observations denoted by x1, x2, x3 and so on, xn of the observed variable x occurs with the frequencies f1, f2, f3 and so on, fn respectively, then the arithmetic mean is given by the formula x bar is equal to x1 f1 plus x2 f2 and so on plus xn fn divided by f1 plus f2 plus fn. X bar is equal to sigma I is equal to 1 to n xi fi divided by sigma I is equal to 1 to n fi. X bar is equal to sigma I is equal to 1 to n xi fi divided by n, where n is equal to sigma I is equal to 1 to n fi. Here is an example to calculate the mean by direct method. Calculate the mean of the following frequency distribution. Click on the Solution button to view the solution.
Let A be assumed mean and x1, x2, x3 and so on, xn are the class marks. Then di is equal to xi minus a, where I is equal to 1, 2, 3 and so on, n. Now d bar is equal to sigma fi di by sigma fi, which implies that d bar is equal to sigma fi into xi minus a by sigma fi. is equal to sigma fi xi by sigma fi minus sigma fi a by sigma fi is equal to x bar minus a, which implies that x bar is equal to a plus d bar. X bar is equal to a plus sigma fi di by sigma fi, which is the formula for calculating mean with assumed mean method. Let us see an example. The following table shows marks secured by 140 students in an examination. Calculate mean marks by using assumed mean method. Click on the solution button to view the solution.
Here is the shortcut method or step deviation method to find the mean of a grouped data. When mid-values xi in the different classes of grouped data are large values, then the computation of the mean xi becomes quite lengthy and tedious. In such cases, calculation is simplified by step deviation method. The procedure to calculate mean by step deviation method is as follows. Choose an arbitrary constant a, also called assumed mean, which is approximately close to the mid-value of the given xi. Subtract a from the values of xi. The reduced value xi minus a is called the deviation of xi from a. Find ui by dividing the deviations xi minus a by the width of the class of the frequency table C. Therefore, ui is equal to xi minus a divided by C. Calculate the mean using the formula am is equal to a plus 1 by n sigma fiui into C. Here is an example to find the arithmetic mean using the step deviation method. The marks of 40 students in a class test are given. Find its average. Click on the solution button to view the solution.
Here are the merits and demerits of arithmetic mean. The following are the merits of arithmetic mean. Unique value, based on all observations, simple to understand, easy to calculate. The demerit is greatly affected by extreme values.
In this topic you have learnt the arithmetic mean am of a statistical data is defined as the quotient of the sum of all items or entries divided by the number of items. Therefore, am is equal to sum of the observations divided by number of observations. Mean of ungrouped data is x bar is equal to sigma I is equal to 1 to n xi divided by n, where xi is the value of each item and n is the number of items. Mean of grouped data is x bar is equal to sigma I is equal to 1 to k fi xi divided by sigma I is equal to 1 to k fi, where fi is the frequency of the item xi. Deviation method for mean am is equal to a plus 1 by n into sigma fiui into c, where a is equal to assumed mean, c is equal. At the end of the topic, you will be able to estimate the median of ungrouped data, estimate the median of grouped data.
Let us learn about the median. Median is defined as a middle item of the given observations arranged in order. Let us see the steps for computation of median of ungrouped data. Arrange the n given numbers in ascending or descending order. If the number of observations n is odd, then the median is n plus 1 by 2th term. If the number of observations n is even, then the median is mean of n by 2th term and n by 2 plus 1th term. Let us solve an example. Find the median of the following. Click on the solution button to view the solution. Here is the next example. The following table shows the details of marks secured out of 20 by 45 students. Calculate the median. Click on the solution button to view the solution.
Now let us have a look at the median of grouped data. The median of the grouped data is obtained by the formula median is equal to L plus n by 2 minus m divided by f into C, where L equals the lower limit of the median class, f equals frequency of the median class, m equals cumulative frequency of the class preceding the median class, C equals width of the median class, n equals sigma f, the total frequency. Here is an example to find median of this group data. Click on the solution button to view the solution.
Here are the merits and demerits of median. The following are the merits of median. Not affected by extreme values. Determined graphically. Simple to understand. Easy to calculate. The following are the demerits of median. Requires arrangement of observations either in ascending or descending, not based on all observations.
In this topic you have learnt a median is the value in the series of data which divides it exactly into two parts when the data are arranged in ascending or descending order. For ungrouped data, when the number of observations n is odd, the median is the value of the n plus 1 by 2th observation. For ungrouped data, when the number of observations n is even, the median is the average of the observation n by 2th and n by 2 plus 1th observation. The median of the grouped data is median is equal to L plus n by 2 minus m divided by f into C, where L equals lower limit of the median class, f equals frequency of the median class, m equals cumulative frequency of the class preceding the median class, c equals width of the median class, n equals sigma f, the total frequency. At the end of the topic, you will be able to calculate the mode of grouped data, give the empirical relationship among the three measures of central tendency. Welcome to this topic on mode. An observation with maximum frequency is called the mode, and it is very useful in trade and industry. For example, for the given set of flowers, the mode is the red rose. Let us see this example. Find the mode of the following data. Click on the solution button to view the solution. Let us see this example. Find the mode of the following data. Click on the solution button to view the solution. Now, let us see the mode of a grouped data. In a grouped data, the observations are grouped as class intervals. Mode is equal to L plus f minus f1 divided by 2f minus f1 minus f2 into C, where L equals lower limit of the model class, the class with the highest frequency, f equals frequency of the model class, f1 equals frequency of the class preceding the model class, f2 equals frequency of the class succeeding the model class, C equals width of the model class.
Let us look at an example how to find mode. Find the mode for the following marks obtained by 20 students in an examination.
Here are the merits and demerits of mode. The following are the merits of mode. Not affected by extreme values. Determined graphically. For group data, it can be determined just by inspection. Easy to understand and calculate. The following are the demerits of mode. Not unique. Not based on all observations. Not capable of further mathematical treatment. Cannot be determined in case of grouped frequency distribution if modal class is at the end of the distribution.
In this topic you have learnt an observation with maximum frequency is called the mode of the data. Mode of group data is equal to L plus F minus F1 divided by 2F minus F1 minus F2 into C, where L equals lower limit of the modal class, the class with the highest frequency. F equals frequency of the modal class. F1 equals frequency of the class preceding the modal class. F2 equals frequency of the class succeeding the modal class. C equals width of the modal class. The empirical relationship among the mean, median, and mode is given by the formula mode equals 3 median minus 2 mean.